Hello everyone, and welcome back to the final lecture in our Python crash course section. In this lecture, we're just going to go through the solutions to the practice activities that we looked at in the last lecture. Hopefully, you got on okay with most of the questions, and if there's any that you weren't able to complete, then now is a good chance to look through and try to understand the solution. Okay, so here we are now inside of the activities notebook. Instead of just reading through the solutions, I'll actually go through and write out the solutions and talk you through the code as we go along. Our first activity was on data types, printing, and variables. We needed to create a few different variables and then print to the console using an F string. I'll go ahead and create the variables and then just assign values to them. So my name, and making sure to put this inside of quotes as it's a string, entering in an integer for age, and then finally the country. To print this, we'll need to initiate our F string, just like so, and then we'll create a message to tie our variables nice together. So hello, and then in here we'll pass in our name variable, which we can do by putting it inside a set of square brackets, and then at the end we can pass in what country we live in. Okay. Perfect. If we run this cell, we'll get our F string, which matches the example given. Yours, of course, will probably have a different name, age, and country variables, but the general structure should be the same. Moving on to activity 2, we were looking at a few different data structures. So starting here with lists. We need to make a list of our 3 favorite fruits. So we can start by creating our variable, and then we'll create our list and pass in 3 different fruits. So I'll go for apples, pears, and blackberries. With our list made, we then needed to index it at the second position, which for my list will be pears. So I'll go ahead and say fruits, and then put 1 inside of our square brackets to index at the second position, because remember, indexing always starts from 0. Next, we had a few questions on nested lists. So for this first one here, we needed to extract the word target from our nested list. If we have a look at our list, we can see that within here we have 3 separate lists. Our first list here containing 1, 2, and 3. Our second list with A, our target word, and then C. And then finally, our third list with just a few Boolean values. We need to select the second list, so we can go ahead and select at index position 1, and then the target word is also at position 2 within this list, so you can go ahead and pull the first index element again. And finally, for our lists, we also had an example with a more complex nested list. As mentioned, there really won't be that many times in Python when it will be needed to work with lists that are this heavily nested, but it's a great example to practice indexing on. Okay, so if we start from the middle of our list here, and work backwards, hello is inside of this list here, containing a few other strings. If we look at the opening and closing brackets, each line is actually its own list element. So at the top we have element 1, 2, and 3, and so on. Our second list on this line, then at the bottom we have our third list. Hello happens to be in our second list, so we'll start there. And looking at the results here, we now have A, B, C, D, hello, and E. To get hello from this sublist, we need to grab its second element, which also has an index of 1 because of 0-based indexing. And this then gives us B, C, D, and hello. So you can now finally grab hello, which is the 4th element in this list, so at index position 3. So as mentioned, this is a particularly tricky list to index, and most lists you'll come across will not be this heavily nested. Next, we had a couple of questions on dictionaries. We had to create a person dictionary with the name, age, and job title keys along with their associated values. We'll just go ahead and create our variable, and then we can add in our information inside of the curly brackets like we looked at before. And then for my values, I'll just use what's in the example below. But feel free to add in whatever you want here. To add a key and value to our dictionary, we can use square brackets as if we were going to index it, But if we use a key that doesn't exist and then assign this index with a value, it will actually create a new key value pair for us. And then we had to print out all the keys inside of our dictionary, which I hope you are either able to remember or look back through your notes and the lectures to find the answer to this, which is just the keys method. And here we have all of our different keys in our dictionary. And then to index our dictionary, we can just pass in the key inside of our square brackets, which for age will return the associated value of 35. And then finally, for activity 2, we had a few questions on operators. We didn't need to write anything for this one. We just had to work out what the output of this Boolean condition would be. To start, we had 1 plus 4, and then our next operation was 8 plus 7. With our comparison operator, which is not equal to, the comparison of 5 not equal to 15 is true. So this operator would return true. And then we had to take this string of operators in Python and use the membership operators to determine if either B is present or is not present in our string. So B in string, which is false, as B is not present, and then conversely, B not in string, which is true. Let's now move on to activity 3, which was on if, else if, and else statements. We had to make a program to classify different temperatures into some different categories based on the criteria below. We already had a variable called temperature, which was set to 11 degrees, and this is in Celsius. The first thing we'll need to do is define our initial if statement. So you could have done this either starting from greater than or equal to 30 and worked your way down, but I'll start from less than 0, then work our way up the temperatures. So if temperature is less than 0, we'll print freezing, and if not, we'll move on to the next condition, which will be, is the temperature between 0 and 10 degrees? So you can say elif, which is short for else if, temperature is less than or equal to 10. We'll then print cold. So now, anything between 0 and 10 degrees will get the value of cold. And then we just have to go through and do this for our remaining conditions. So I'll go fast forward and do this now. Finally, we can add else to cover all the other cases where the temperature is above 30, and this will just be classified as hot. And then if we run our code with the value of 11, it'll print moderate, which is correct. Activity 4 was on loops. And starting with the while loop, we needed to create a loop that started at 1 and would double the current number in each iteration until we reach 64. We'll start with the current number variable, which is set to 1, and we can then go ahead and say that while our current number is less than or equal to 64, we want to print our current number, and then we'll have our increment, which instead of being the number plus 1, like we did before, it'll be the current number multiplied by the current number times 2. Or as a shorthand alternative, we could have done this. It would also be possible here to say while our number is less than 65, when we run this, we'll get our output below, which matches the example. And then for our for loop, we have to create essentially a multiplication table for a given number, which in this case was 25. So from 1 to 10 times 25. We'll need to start by creating our for loop. So we can say for I in range, and then our start value will be 1, and our stop value will be 11, as the stop value is not included in the range function. Then we can use an f string to print out our answer in the format of number times I is equal to result, where number is the given number of 25, and I is the current iteration value of our loop. And then result is just our number multiplied by I. So let's go ahead and write this in here now. Then the output we get matches the example. So this is activity 4 boxed off, and we're now ready to move on to activity 5 and activity 6, where we'll focus on functions and lambda expressions. For this one, we just needed to create a small simple function using the modulo operator to determine whether a number is odd or even. And this is an example that we've already looked at in this section. We can start by defining our function with the def keyword, and then we'll have our function name. So I'll call mine is even, Then we'll have to set up a parameter to pass in a number. So I'll call mine number. And then for the code, we'll have a condition of if our number mod 2 is equal to 0. And this will check if the remainder is equal to 0. If it is, then this will mean that the number is even, because all even numbers are divisible by 2 with no remainder. If the result of this is true, we'll have our function return the Boolean value of true because the number is even. But otherwise, it'll return false, and we can check that this works with our 2 examples below. After this, we had a couple of questions on lambda functions. We first had to take this regular function here, which doubles a number, and then convert it into a lambda function. As we know from our previous lectures, we need to start our lambda functions with the lambda keyword. So we'll have lambda, and then x for our parameter, and then we'll just have this return x multiplied by 2. And then we have to take our lambda function that we just made here, and then apply it to this numeric list here. We'll call map, and then our first argument will be the function that we want to apply, which we can copy and paste from above, and then we'll apply this to our numeric list provided here. And before you can access this list, you'll have to make sure that you run the cell. And then it will cast our output to a list, and perfect. So we now have our list of 1 to 10, but now each element has been multiplied by 2 as a result of our lambda function. And then to finish off our activity on lambda functions, I asked you to convert the isEven function that you created in activity 5 to a lambda function, and then use the filter function to apply this to the numeric list sequence in order to filter out any odd numbers from that list. And then to create our lambda function will be very similar to before. So we'll start by initiating our lambda function with lambda, our parameter, and then our code will be where x mod 2 is equal to 0. And then to apply it to our numeric list, we'll start by calling list to cast our result to a list, and then we'll add in our filter function and the required arguments of the function, and then our numeric list sequence. And looking here at the output of this, all the numbers returned are now the even numbers inside of our list. So we're now on to the final activity of this lecture, which is activity 7. And there's quite a lot to do in this activity. And to make this work, you would have needed to use quite a lot of the topics that I've covered so far in this section. If you didn't manage to complete all of this or get it fully working, then don't worry, we'll go through the solution now. And as mentioned, this was quite a big activity. A good starting point for this activity would have been to go through and make our 4 functions for add, subtract, multiply, and divide. So that's what we'll do now. Starting with add, we can define it and then provide our 2 parameters. The code will just return these 2 parameters added together. And then I'll go through and fast forward again and fill in our remaining functions. For our divide function, one thing that you could do is add in a check to see whether the final number is a 0, and then handle the error if it was. But I'll leave it out for now, as we haven't covered this and I don't want to add extra complexity. The next thing to do is allow the user to choose the operation that they want to perform, so whether it's plus, minus, multiply or divide. And to make this work, we'll have to use a function that we haven't covered yet, which is the input function. And this was mentioned in one of the hints provided. Basically, the input function allows a user to assign a value to a variable after the code has been executed, as opposed to before, where we give a value before we execute or run the code. Another key part here is that it's also mentioned that we need this program to run continuously until the user chooses to exit. The best way of achieving this would be to use a while loop. To start with, we'll display our list of options with which number will select which operation. So 1 will be add, 2 will be minus, 3 will be multiply, and 4 will be divide. And then at the bottom, we'll create a choice variable where we'll ask for the user input by using the input function. To make this code run continuously, we'll put it all inside of a while loop. So while true, our print functions, and then also the input function will run continuously. And then we'll have to make sure here to add some indentation to this code, which we can do by selecting it all and hitting tab. And we'll have to do this as we need our code to be inside of the while loop. If we run our code as it is, we get to enter our options, but nothing happens yet, as we've not told our program what to do with our inputs. To make something happen, we'll use an if, else if, and else statement. The first thing to cover is our break condition, which will allow our user to exit the program. We can say that if choice is equal to 5, then we will simply break. And as we looked at before, break simply exits out of a loop, so it'll break us out of our while loop. To make this a little nicer, we'll also add in a print function above this just to say that the program has closed. With our exit condition sorted, the next thing we'll need to do is ask the user for the numbers that they want to input. So we'll now create two new variables, num1, and below this I'll do num2, and these will just ask the user to input a number. It's important to wrap this inside of the float function, as by default the input function returns a string data type, which we will not be able to do anything with. Then below this I'll do the same for num2. The reason that we put our exit condition first is because this is the first thing that we want to ask. So if they want to exit, we don't want to ask them to provide any numbers. And next, we'll just need to add in our choice condition. So if their choice was equal to 1, which as we can see here is the addition option, we'll create a variable called result, which will be equal to our add function, with our two arguments being num1 and num2, which are the two inputs we created before. And then I'll go through and do the same for 2, 3, and 4 by using the else if statement, and just of course calling the relevant functions for each. Finally, we'll add in an else statement for any number that isn't 1 to 5, and we'll just say that this is an invalid choice. Then below this we'll add in continue, which will end the current iteration of the loop, which will be this loop here, and then take us back to the start of the next loop, which is the while loop, so the program will repeat. And then finally, at the bottom, we'll just print out our result with an F string. And let's now run this and see if it works. Okay, it's looking good so far. We get our 5 options between 1 and 5. And let's try add. So I'll enter 10 and 5. And then, yep, we can see here that we get our result of 15. The program then runs again. So let's try multiplication this time with our values of 10 and 5 again. We'll get 50. And then finally, we'll check our exit condition of 5. Okay, perfect. So this is all working fine. So one thing we haven't done with our program is add in any error checking or any error handling. But for the purposes of this, which was just to get to grips with Python and understand how to use it for our data analysis going forward, then this is completely fine. Okay, so really well done here. I hope you managed to get through the majority of these activities. We'll be using Python plenty more throughout the rest of the course, so there's lots more opportunity to practice and apply what we've learned here. And this is now our Python crash course section complete. This has been quite a long section, and we've definitely covered a lot of content here. I hope you found the solutions lecture to be valuable, and of course I'll help you out with any questions that you might have down in the Q&A section below. Thanks everyone, and I'll see you in the next section where we'll begin looking at NumPy.